Welcome to the Podlets podcast.
Good afternoon, everybody, and welcome to episode 21 of the Podlets. In this episode, we're going to explore orchestrators and runtimes, and we're going to just kind of break into those topics and maybe talk about a couple of things that we've seen. It should be pretty fun. It should be a pretty fun discussion. Today, I have with me Josh Rosso.
Hello.
I got Michael Gauch.
Hello.
I got Olive Power.
Hello.
And away we go. So clearly, one of the orchestrators that we've all heard of is Kubernetes. So to get that one out of the way, but I think we should probably dig into what it means to be an orchestrator. What is an orchestrator in this particular context? Does anybody have an idea?
I'll start. I mean, simply, it seems to be something that's going to kind of manage something. And manage is probably so packed with different aspects of what it manages, right? It could be managing the life cycle of something. It could be managing where something starts running. There's just so many aspects. But I think at a high level for me, an orchestrator is usually managing some kind of lower level functionality.
So there's some crossover there for scheduling and for I guess that's a form of orchestration for sure. Yeah.
Right. Yeah.
Yeah, and I think we have also a lot of VMware folks listening to this podcast, and there's this famous, almost coined legacy tool called vRealize Orchestrator, which happens to be around, I think, for more 10, 15 years. And so this orchestrates workflows. So that is kind of a different take on orchestration and orchestrators there. So do we want to scope it to the container landscape, or even in the cloud native landscape we have orchestrators like Airflow, etc.
No.
So we keep it open here.
Yeah, let's keep it open. I think it'll be fun to talk about the different orchestration models that we've seen, and maybe what differentiates them. That'd be kind of fun.
Yes, cool. Yeah, I just wanted to throw that in.
So I spent a lot of time on the Windows side of the world, and we had a lot of orchestrators there. I used to work for a security defense sort of account, and a lot of those accounts had sort of orchestration in and around content of what was on your desktop, right? So that was kind of maybe everybody's initial sort of introduction to orchestration. It certainly was mine. It was how do we regulate the content of a corporate desktop, and how do we regulate all the applications that are on there, and the version of the operating systems that's on there, and the versions of the software that are available to users. So a lot of my sort of initial toe dipping into the orchestration world was in and around that. It was enterprise sort of desktop management from a corporate level, and how do corporations that have 50, 60, 70, 100,000 desktops, how do they maintain the content of those desktops at a level that satisfies corporate security, corporate content from an application level, and sort of corporate visibility in terms of who's installed what from a licensing perspective. So yeah, so that there's a lot of tools in that space that have kind of grown up, to be very mature. And I worked on a one called Novodyne, which eventually sort of was bought out by HP and became Radia. But, there was other sort of tools in around that space, SSCM, which is kind of desktop management. And, they're very important tools, and they maintain a desired state. We talk about declarative states in Kubernetes, and these sort of tools sort of define that sort of element of declaring how you want a system to look like, or an endpoint to look like, and then your central management system would maintain that desired state from a central perspective.
That's a good point. That's an interesting one too, because it's also kind of wild to think about the different challenges that orchestrators have. Right, in that particular case, you have laptops that could not be connected for months or for years.
Totally.
And you're going to have to as an orchestrator, you're going to have to be ready to figure out what to do. And how to determine what that desired state or actual state is.
Yeah, it was super interesting because it was a defense system. There was a lot of endpoints. We were talking about submarines and sort of deployed kind of laptops. That would check in every 6 months, so trying to manage that sort of like perspective where they'd come in and the download for everything to be updated, had to be as slick and as smooth as possible. So you had to make that you had to make sure that your proxy endpoints were like pre-cached with all the data that those folks needed for a quick deployment down onto their desktops to make sure they had the latest security updates. As a mandatory installation, and then lots of stuff was set as an optional installation, right? So we were trying to maximize the time spent in the office, in terms of them getting their security updates, and any optional updates could be done sort of in their own time. So it was super interesting to try and design that sort of system that people could kind of like select their own installations, but you kind of made stuff mandatory in the background. So the minute they connected up to the network, you'd have a service running in the background that kind of immediately detected that and said, oh, you're on the office network. Wow, okay, you've got a lot of stuff that mandatory needs to be installed right now, and we'll do that in the background. But also, hey, here's this catalog, and there's this new cool stuff that you can install if you want as an optional sort of level. So it was like really interesting. But, the ultimate end goal was like, there was like baselines that need to be maintained, certainly from a security perspective. Like, okay, everybody needs to be on the same level from a security perspective. And we're trying to like get 100% patching level maintained, and all our devices need to be patched, to the latest patching system so we can satisfy our security requirements. So that's kind of like that was almost like the first KPI. And then, installation of new versions of software, for example, for them to order new kit, or for them to order, from a medical perspective, new blood samples, for example. All of that sort of software was kind of like almost secondary, but still that was kind of a secondary KPI. So it's super interesting stuff. So there was a lot of technology that evolved in that space in terms of automation, try to figure out where a user was, whether they were like, at their home location in terms of office, or whether they were roaming to a different office, so they'd get a different roaming profile, and therefore the software available to them was maybe limited because he didn't want to download software onto a desktop that wasn't their own desktop from a licensing perspective. So it's all super interesting.
Hey Duffy, you're on mute.
Thank you. I was going to say that's awesome, and I think that what's funny about this is that the title of the episode is Orchestrators and Runtimes, and if we think about the runtime aspect of this, it's going to be this like incredibly stateful, can't be recycled like machine sitting on a submarine or in a person's backpack or what have you, right? And so it's kind of a in a way that is the runtime that is being orchestrated by all of this system. Kind of a pretty interesting example.
Yeah.
Michael, did you have some?
Yes, I got a question. So I think summing the first 5-7 minutes up of this episode, we started with Kubernetes on orchestration as the container orchestrator. Then we went on my famous tool, the vRealize Orchestrator, as an orchestration workflow orchestration. Then we went into the land of desktop management. So certainly there's different views and definitions on workflows and orchestration. And what I like, Joe Bida, I think 2017 or so, he wrote this article, Jazz Improvisation over Orchestration, where he describes the Kubernetes model, the controller model, how they interact with each other. So that it's not really orchestration what's going on. And this kind of tripped me because we talk about Kubernetes as a container orchestrator, orchestrating something. Like you think of a big machinery and then it places things somewhere else. But then you look into the machinery and you see like there's no orchestrator, like there's no central piece that orchestrates. It's all of this like flow, this dance or choreography that Joe describes in his blog post. So I want to throw in like, is Kubernetes an orchestrator at all?
I think that it is, and I think that already in multiple of our conversations just so far, in like the 9 minutes we've been talking, we have conflated orchestration and scheduling because in a way, orchestration is a form of scheduling, right? Yes. So absolutely, I do think that Kubernetes, the sum of its parts, it is an orchestrator of runtimes. It can schedule those things. It can understand capacity. It can take corrective action if things, if particular controllers that are running within Kubernetes can take corrective action if they don't see things happening. And for something, from my opinion, these are the responsibilities of an orchestrator.
Mm-hmm. Good.
Josh, what do you think?
Yeah, I'm on the same page. I think if I take 20 steps back and look at Kubernetes, I see an orchestrator. And then to your point, Michael, if I take 20 steps forward, I see all these, parts, these controllers and different aspects that have isolated concerns that in and of themselves don't feel like they're orchestrating anything, but together they feel like they're achieving that. Right.
Yeah.
Exactly.
Yeah.
Yeah.
Nice.
I think the way that Joe put it was jazz improv. And I'm always a fan of that one. Because
Yes.
all these incredible artists doing all this incredible work, all on stage, all on the same stage at the same time, and that is the result, like
Exactly. Cool. Okay, so we got my first question answered. So second one, orchestrators and runtimes. Is Kubernetes a runtime then, or is it an orchestrator?
I think it's an orchestrator. I think the runtime is actually delegated. And what's interesting is that runtime can be delegated to a number of projects. It could be, probably by far the most common would be to use Docker as the runtime, but there's also Containerd. And what's interesting, again, kind of in that jazz improv way, right, is that the coupling where Kubernetes ends and the runtime begins is the kubelet, right? The kubelet is not creating it's not initiating these processes. It delegates that work to your runtime.
And my view of the world is that the success of a runtime, right, or a runtime becoming somewhat ubiquitous, it oftentimes is what creates the need for an eventual orchestrator to some degree, right? And we see this right all over the stack, but containers are such an easy one. Like, container technology has been around forever, but with the advent of Docker and people becoming more comfortable using containers, seeing their value, over time you get to this point where this runtime is becoming so commonplace that someone takes a step back and is like, maybe we should build an orchestrator that can act at a higher level to ensure that we can trigger these runtimes at various locations and do all the scheduling concerns and so on.
In this particular model, I think it's also related to the fact that your runtime has a form of packaging associated with it, right? And we're going to get to this next part here in a minute, but I think this is kind of mind-blowing. But yeah, so like with Docker, you have Docker containers, Docker images that you can pull down. You have this whole image registry idea, right? And that in itself was like incredibly compelling. And I think that also really pushed toward, well, all this is great, but we're going to need to know how to do this at scale. We're going to need to figure out how to do this across multiple machines and actually efficiently do this across those things. So you're right that it did precede the need for an orchestrator.
And I think that's the key word, right? At scale, Duffy, right? So the runtimes can kind of operate on a kind of localized level, but when you start talking about at scale and how you want to like manage that sort of the execution of your application or on that runtime, then that's where the orchestration comes in, right? That's the kind of, that's exactly what Joe was on about as well. So trying, manage these things at scale, localization is one thing, at scale is another thing. And that's where the orchestration sort of layer comes in, I think.
I want to take sorry, Duffy. Oh, thank you. I want to take a stand on Kubernetes is a runtime. So I basically want to take an opposite position here, because if you look at runtimes, taking Docker as an example, which we say it's a runtime in the sense or in the perspective of Kubernetes because it's a container runtime that implements the container runtime interface that the kubelet is using, right? As you said, Duffy, the kubelet is kind of the execution engine where then it delegates all these operations, these lower level operations, to certain runtimes, container runtimes, networking, etc. Now, if you look at the container runtime Docker, it does nothing else but dispatching that to kernel primitives, C groups, namespaces. Yes, it does some volume management, something around that. But at the end of the day, it's kernel primitives that are being called. So it kind of defers and delegates this to the kernel. And then if you look at what the kernel is, it's kind of the heart of the operating system. So it becomes a runtime for operating system. Other processes like systemd is also a runtime for processes, or any other process, which, for example, if you ship a Go binary, it has a Go runtime. So I think some of the confusion in our industry is because sometimes we use words loosely, and I like including myself, and then that confuses people who are new to this field when they hear about runtimes. Is Kubernetes a runtime? Is it an orchestrator? And so, from a definition of a runtime, and I did some preparation for this show just to like read myself up on what a runtime is. It seems that there are kind of runtimes. There can be a runtime of runtime and a runtime of runtime. So encapsulation, which is the Docker runtime, happens to be a runtime for Kubernetes, but then it's run on a kernel, which happens to be the runtime, and it happens to be run on infrastructure, CPU, which happens to be a runtime as well. So there's this encapsulation. And looking at Kubernetes, I would say it's a distributed runtime, because all of a sudden, yes, we have an orchestrator, but now we are dealing with Knative and all the higher level tools, paths, and frameworks on top of it, where now Kubernetes becomes a runtime for these higher level functions like OpenFaaS or name any other thing that leverages Kubernetes from a distributed management perspective beyond orchestration. And so that's why I want to throw in that Kubernetes could be considered a runtime. In that sense.
That is an interesting point. So it's like, so your point is that at some point the orchestrator may become a runtime at a higher level of abstraction.
Yes.
Yeah, I think it's interesting. Like you've identified that at least in my brain, I think the highest level abstraction, I oftentimes view that as the orchestrator to me, right? With Kubernetes is usually my entry point, my highest level abstraction. But to your point, if I took a step deeper and I was focused on using Docker day to day, it's totally fair to think of Docker as an orchestrator of those kernel primitives, right? Just as you had put it. So it's funny how it's kind of all these turtles all the way down, right?
That is an interesting case. So I think, also I think the container orchestration and runtime is like a square rectangle problem, right? Mm-hmm. Where you can have a runtime and no orchestrator.
Right.
But likely, if you have an orchestrator, you have some form of runtime.
Agree. Yeah. So there's a link that I put into the HackMD in the show notes where I think it's a computer science class from Italy, where they discuss what runtimes are. And as we know, the JVM is a runtime. We know that containers, Docker is a runtime. We know that the kernel is a runtime, etc. So they talk about these layers of runtimes. And so but they don't talk about Kubernetes, because I think that class was before the time of Kubernetes. And so I thought, well, if there's runtimes of runtimes and this encapsulation, maybe Kubernetes itself becomes a runtime, because now we use all these distributed primitives to write new distributed software on top of Kubernetes, deferring a lot of the complexities of like self-healing, volume management at scale. Like Kubernetes has its own volume implementation. Yes, it defers certain things, but it translates. Like you create a volume in Kubernetes, but you don't directly create the Docker volume, right? So Kubernetes is your runtime. And then it happens to have these implementation details, other runtimes to defer and delegate to them. So that's why, like in my view, I would consider Kubernetes also a runtime for writing distributed systems.
That's a reasonable argument. That's a reasonable argument. And I think it's, like if you think about it, like it's even got something of a guarantee of portability across the runtimes, right? So your implementation of Kubernetes should be somewhat portable.
Right.
Very similar in some ways to thinking like, if I write software for a Windows platform, I have to like write that software for any of the different Windows environments in which it might execute.
Right.
Which I think is like another interesting output of this. Like, well, obviously, orchestrator is a very big word and it can mean lots of things. And we've already, as we've already described it, like it's hard to fully encapsulate what orchestration means at a lower level, but at a higher level, we just know that it's the thing making the decisions about stuff that will be done. But in a runtime, can we say that a runtime is an execution environment? Is it a place where processes, consume resources and they make things happen? Like, is it where the rubber meets the road, as it were? Is that a runtime? And is that how you encapsulate it in your head? Like, if I delegate an amount to work to a Kubernetes cluster, effectively using Kubernetes as a runtime, I might still think, that's the place where that application runs. So it's the execution environment for that application. And then when I dig down into the details of that particular Kubernetes cluster, and I see that particular process associated with that pod, it's being implemented by Docker on top of this Linux kernel. Is that the execution environment? Like, is that a mapping?
So according to Wikipedia, there is. and they talk about runtimes as part of an execution environment, but not the execution environment. So the example that they give there is a C binary that you write your code, like your logic, but then the compiler and like all the stuff that gets baked into your binary during linking and all the stuff that makes it actually an executable, that has that is the runtime, in the sense of it takes care of all the things that you don't have to take care of in your code, which is setting up stacks and linking other stuff in. And so they describe the runtime as part of your execution environment or your execution context, but not necessarily the same. Like they don't say that a runtime is an execution environment. It's just a part of an execution environment, which happens to be the pieces that you then add to it, like your code.
So you're defining runtime in the way that people might define Node.js as a runtime, or or Java as a runtime.
Yes.
Okay. Interesting.
So, like taking that further, could we? I mean, I think from my perspective, for me, Kubernetes would be an orchestrator, but in this context, it would probably be more like a platform, right, to run your applications, and it can support whatever application that is in terms of runtimes. When we talk about runtimes, as Duffy said, it's Docker or it's Containerd or it's RKT, whatever that runtime is for your application. Kubernetes will support that as a platform rather than a runtime.
I think the level of, I mean, when we talk about the abstraction of what runtime might mean, like I think it makes sense. I think I could hear both arguments, but certainly, depending on how it's almost a matter of perspective, right? As infrastructure people, we look at it and we're like, that's a platform. That's a thing where, I can build things on top. It has a bunch of primitives I can consume. It's AWS. It is a platform, right? Like, or, it's infrastructure as a service or platform as a service, depending on the kind of constraints around it. As a developer, you might look at this as, well, like, is it taking care of a bunch of work that I don't have to deal with for my application, right? Is it got a bunch of built-in functionality? Is there like a built-in library that handles things like, date time and, all of the other stuff that I would normally have to actually code myself? And is that a runtime? You know what I mean? Like, and so I do think it's an interesting perspective when we think about it, like, how different people view the same thing different ways.
Yeah. That's why I just wanted to take this stand here, because I think some of our listeners have this confusion of like, okay, they talk about continuous orchestration and runtime, so it's not an orchestrator or it is an orchestrator. But I think looking at different perspective helps us to say like, well, maybe it's both or even more, like Olive said. Maybe we consider the platform, right? Just to keep the show going.
Yeah. So it's definitely one of my favorite ideas in this episode is that when we talk about orchestrators and runtimes, you may be coming to this episode thinking that we're talking about Kubernetes and Docker, because that's the simplest way to think about this, right? Or for most people who are like familiar with Kubernetes, that might be the way that you think about it. But if you think about it, like if you take a step back and like squint a little, as Michael has has pointed out, like an application is an orchestrator. Right? Functions within your application might be the equivalent of that at runtime, like threads in your application, basically moving things back and forth. And to Josh's point, as those functions or parts of your application become more popular and grow in popularity, and you realize, wow, I need to be able to scale that. I need 20 things to be able to handle the amount of load that's coming to that particular function. Whoa, microservices, right? Like, let's break these things up and make them so that they're scalable. Now we have to think about, what problems from an orchestration level do we have to think about at the application layer so that we can support those things. And now I have all these other requirements. Like I need to be able to actually handle the life cycle of those functions that I've broken out. How do I do that? And that's where Olive's point is like, you need a platform. You need something that's going to express to you primitives that enable you to handle that part kind of automatically, the way that you don't have to think about daytime unless you're on Java. But anyway, but yeah, I mean, like that is like definitely my favorite idea of this episode. Anybody familiar with other examples of runtimes or orchestrators?
From back in the CoreOS days, we had an orchestrator called Fleet. If you recall that, Duffy, I'm sure you do. So that was an orchestrator that attempted to orchestrate systemd units, which was really cool. And what's funny about systemd, or sorry, not systemd, but Fleet back in the day is I worked with a couple customers when Kubernetes was popularizing, where they actually used Fleet to bootstrap the systemd units that would then run their Kubernetes cluster, right? So think like it orchestrating the kubelet and the API server back before we typically ran those as containers themselves. So that was a really cool one. I think it's officially deprecated now, but it had a cool evolution.
That is neat. One of the fun things about that one was about that particular model for Fleet, and actually to some degree Kubernetes as well, is like, thinking about what we did before and how we came to trying to solve that problem using something like Fleet or even Kubernetes, right? Like before we would use, and this is kind of related to the way that Olive was talking about, like the Windows environments that you were working on. Before we would do this with Ansible or Chef or Puppet or one of these other tools, right, in which we have 1,000 machines, we have some subset of machines that we need to deploy some subset of applications to. We would write orchestration and automation to handle that, right? We have to go out and inspect that node or one of those nodes, some subset of those nodes, determine what it looks like, figure out if we can get it to where it needs to go, and just continually do that over and over and over again. And what was fun was that when we got to Fleet, when we got to things like Kubernetes, we flipped that model on its head. Instead of going out there and trying to figure out what the world looked like from there, we kind of expected it to, we kind of moved the responsibility for sorting out that work to the endpoint. And now we just figured out a way to make it so that that endpoint could be informed when there was more work to do, rather than pushing that logic, rather than telling that thing, okay, here are the things that you must do and you must do them now, and I will wait until you are done. We're saying, here's what the desired state is. Get to work. Good luck, buddy. Like, which is kind of and we've done this lots of times with different orchestration models over time too. Like if you think about the way that, even monitoring systems, looking at the way monitoring systems have changed or evolved over time. Like for a very long time, the head end of your monitoring system would literally go and connect to the however many X number of machines that you have, execute code there, and then bring back the answer, which is probably not the most efficient way to go about that, right? And then you see things evolve over time, and you see, okay, well, maybe I want to have the execution be something that I just farm out to something running on that node, and I can just scrape that endpoint for information. And some of the other cases I've seen are things like Ganglia, where instead of actually going out to scrape the other endpoint, you have all of those endpoints just put something, multicast it up to some central endpoint, and it pulls all that, and your central endpoint is just responsible for serializing all of that information coming in from everybody. And so like this is just one of the many examples of where we've actually tried to think about orchestration differently as we get to a level of scale where we have to solve our problems because the popularity of our application or our runtime has kind of taken over.
I still remember the container orchestration wars. Who remembers these?
Did you say wars, Michael?
Yeah.
Yes.
So like the Mesos versus the swarms versus the Kubernetes, and then often forgotten is the Nomad, HashiCorp Nomad, which happens to still be around, right? And interestingly, and Duffy was just touching on this, these four, like Nomad, Swarm, Kubernetes, and Mesos, they had completely different implementations of container orchestration, if you will. And there's been this long debate of like who won, and I mean right now we know who won, but why did Kubernetes succeed? And it is going back to what Olive said, is it is this platform thing, right? We don't talk about it as a container orchestrator anymore, but as a platform to build platforms, right? And so that, I think that was the main reason why Kubernetes succeeded, because the way it was designed to do so. That's a point back to Olive. So I think she's spot on with the platform. I just realized.
But it's interesting as well because the whole containerization thing as a runtime sort of usurps the whole stagnancy around updating applications and around sort of long life cycles to release applications, and when that release was ready to go, the sort of the reluctance to update in the light of potential failures. Because I talked about before desired state in the platforms I used to manage before, and it used to be super interesting because we had this facility where we could kind of say, listen, we know what the desired state is from a central perspective. We can kind of run a scan of all the endpoints and find out, which ones are actually at desired state in terms of all their applications, which ones that conform to the desired state of the central system, and which ones are not. And what would the changes be if we were to apply that desired state in terms of file changes, application updates? And we'd run that report sort of fairly regularly to kind of to highlight to various teams to kind of go, what, your application's kind of way out of date, and there'd be a lot of reluctance to update the application because there'd be so many changes that were kind of queued up for update, but were never actually sort of triggered because there was just a reluctance because of the slow release cycle, that maybe we see now, and we're trying to transform with containerization and microservices, and that, my application is working fine, and I know there's an update to it, but that update doesn't really affect business function right now, and so I'm just quite happy to leave the application as is. So 3, 4, 5 updates later, that application is now behind, and it was just really super interesting from the platform / orchestrator that it could say, listen, you're 5 updates behind, and there's 100 file updates that need to be applied. So whenever you're ready, we'll apply those. And it was kind of it almost got to the stage where they would okay, we're not going to apply those. There's too many. We're not going to actually do that. We're going to rewrite the application or something and host it somewhere else. So from an orchestration sort of platform perspective and management of that, it was super interesting that the orchestrator could, know what the desired state should be and report back to the management team, what was in and what was out in terms of, what the desired state should be. It was always a super interesting report to run.
Right.
So yeah, the whole containerization stuff that kind of allows these kind of quick releases without affecting anything else, kind of changed that. But, at the time there was always this, we'd sit around and kind of go there's 20 updates that need to be applied to this endpoint, and nobody wanted to apply those updates. So it was kind of then there'd be 21, then there'd be 22, and so nobody wanted to apply those because everybody's stuff was affected. And it was just interesting times.
Hey Duffy, are you on mute? You're on mute. Yes, we can't hear you.
I feel like all of us here chase that to some degree, in our own ecosystem, or in our past lives. Or,
Hey Duff, I think your audio is really mangled, man.
Yeah.
Okay, I'll try and fix it.
Bitrot.
While Duff is getting that together, I was going to ask, it kind of related to what Olive was talking about, and then you prior, Michael. I wonder if there's any kind of guidance or experiences we have with determining when you might need an orchestrator. It's kind of like the episode we did a couple weeks ago, which was Should I Kubernetes, right?
Right.
And, I think a lot of the kind of FUD around Kubernetes as an example oftentimes comes from not actually needing an orchestrator, right? Perhaps running containers with a Docker runtime or Docker orchestrator, however you want to qualify it, right, is actually adequate. So if you're listening to this podcast and thinking, do I need to introduce an orchestrator? What are some of the signals that we've seen that would show it might be interesting to, or might be worthwhile exploring that?
Do you want to go first, Olive?
Yeah, so I guess from that whole, you're right, Josh. Sometimes, like what I spoke about before, sometimes there's an element of over automation. Some people don't want all this automation happening in the background. It's we don't want to push the latest updates. We don't want to sort of have these latest versions because we just kind of want to do it a bit more sort of piecemeal approach. So the over automation, or the sort of the huge automation that Kubernetes provides, sometimes is not always what people want. They're quite happy just to kind of run them, as I say, bit by bit themselves. But I think that the whole, Kubernetes is it's an orchestrator, but it's kind of combined with the whole applications that it's trying to
Yeah,
orchestrate in terms of the
exactly.
containers that it's running, right? And
Yep.
the applications that it's running. So that's when that sort of comes into play. So when things want to be released quickly and customers are ready to be that kind of agile and ready to run fast, that's where that orchestration and that like orchestration to me kind of mean, under the covers to me it's automation, right? Back in the day we all used to write scripts to do this, right? In sort of manual scripts to do this, and a bit of script to do this and a bit of script to do that. Kubernetes is kind of bringing that from an enterprise perspective and doing all that for you. But you have to kind of understand that like what it's doing under the covers is kind of what you want it to do. So you have to be ready from a end user perspective, or the person whoever's consuming Kubernetes. You have to, the applications that it's orchestrating or the containers that it's orchestrating, they have to be those kind of applications that kind of run at speed. Applications that are kind of slow running don't really benefit, in my opinion, from like the super orchestration that is Kubernetes.
Yeah, I think for me the lines are blurring these days a bit, because it's so hard to find a project that does not leverage Kubernetes. Once you want to build a new app, something like that, and then you feel like, okay, I need a database. Well, okay, here's your Kubernetes database on Kubernetes. So Kubernetes became so ubiquitous that it's almost impossible to get around it, because all these artifacts that we get, like software, is almost like shipped for Kubernetes. So you need Kubernetes to kind of assemble the pieces together. I think where I would not use Kubernetes is this project where I have a very clear picture of the requirements, meaning, okay, there's a single app that maybe like an older app, or it's just written in a way that doesn't need scaling. It's pretty static, as Olive said. It doesn't require any sophisticated configuration management, etc. And I just can roll it out with primitives like systemd primitives, right? And systemd is perfectly fine as well. It's kind of also a local host orchestrator, which kind of can keep it up running and other stuff like that. But that's where I was saying the lines are blurring. We were building an appliance for some automation, and we were asking ourselves, should we Kubernetes for the appliance? And the appliance itself is just one appliance, right? It's like not multi-scale out, and it might not even have to be. But we were using Kubernetes for two reasons. First, the software that we required to like put in there some fast backend is being shipped for Kubernetes and maintained for Kubernetes. So that was like we could do it without Kubernetes, but like there's so much momentum around Kubernetes for this software as well. So we use Kubernetes. That's the first checkbox. And second, we weren't sure for customers adopting this appliance whether they would come around and say, look, we need scaling, we need HA, like higher availability, because this software is so critical now, part of our infrastructure. And so we didn't want to go back and rewrite our whole architecture, because we missed that decision in the early days. And so even though right now we would not have needed it, we were just looking ahead and it's like, okay, maybe we need those scale out features, etc. And that's why we decided to go Kubernetes, where today it would have been fine without.
Yeah, you both like perfectly encapsulated my experience too. Like I see two avenues constantly, right? Which is, one is, now that Kubernetes is getting more ubiquitous, to Michael's point, doing certain things is just easier on Kubernetes, believe it or not, because people are designing for it. They're setting up ways to deploy easily, run things easily on it. I think that's going to continue. And then there's another one, to Olive's point, which is like, I like that parallel with the notion of automation a lot. Like if you want to take your automation to the next step to some degree, right, Kubernetes could be viable if it's justified. Like an example that I oftentimes run into is I'll work with shops where they deploy a lot of their containers using Ansible. And, maybe you could even think of Ansible as an orchestrator. Like I know technically config management, so on, but there's parallels there, right? It can talk to Docker, it can run the container.
Yes.
And for a lot of groups, like that is super, super adequate. Yeah. The extra layer of Kube is totally not justified for them. But a lot of them get to that point where it's like, oh my gosh, if I could just declaratively state how I want this app to run, and it goes across all my runtimes, be it Docker or otherwise, I won't be managing as much Ansible automation code. My declarative state will be a lot more Kubernetes focused or container focused rather than Ansible, which is a tool for a lot of things, right? So it's really kind of finding when you hit that tattered edge, or sharp edge, I should say, right? And knowing that it's a time to jump to maybe a more mature orchestrator.
Right. Oh, no, it's not better, Duffy.
I was going to say, are there parallels here between, like the same question you might ask about when it is time to break up that monolith into different services and stuff, right? Like, are there parallels there with relation to when you want an orchestrator for your infrastructure? Are some of those questions the same? Right? It's like continuing that parallel track, like in an orchestrator as an application, runtime is perhaps just threads or particular functions that you've gotten into it. Like, is there a parallel there as well as from an orchestration perspective? And it sounds to me a little bit like, from Josh's perspective, it's there are, right? Like, I mean, once you get to a certain level of automation and you realize, what, we need to be able to do this at kind of a larger scale, then you start shopping around for a better orchestration model to be able to enable that. And whether that new orchestration model is moving from Puppet to Ansible, or moving from any of those configuration management tools to something like Kubernetes, because you can better schedule processes on those machines and handle the life cycle of them. Like, when you're evaluating those different orchestrators, it becomes kind of an interesting set of questions.
Yeah, it's a bit hard to follow, Duffy, because your audio is really like chopping up. I don't know. So I had one comment for Josh, which is on like you were asking this question: when do I need an orchestrator? Kind of this: should I Kubernetes or not? There's also, and I don't want to get into that flame war, but there's this kind of, I'm not going to do Kubernetes because it's way too complex. I'm going to go serverless. Like, I'm all in AWS, so I'm not going to do Kubernetes, right? And so the beauty of this episode is, even though we talked a lot about Kubernetes, the title is Orchestrators and Runtimes, right? And so even though you might be using some higher level framework or platform, call it Lambda or whatever, under the covers, there is an orchestrator that orchestrates these little functions and containers somewhere in the platform, even though you're not using it, right? But there is an orchestrator. So I think even there, this episode makes sense as well, because we are sometimes not even knowing that there's an orchestrator in play. In the case of AWS, it's a custom one, right? It's not Kubernetes in this sense, at least for certain parts of the platform, but there is orchestrations going on. There's runtimes, right? And so I think that is also something to consider for our audience as well. Even though we touched a lot about Kubernetes, orchestration, runtimes, it's safe to assume under the covers there's always an orchestrator doing things, even though you might not be using it directly or knowing it about it. Yeah, I just wanted to throw it out.
No, I love that. And I think, one thing I've become convinced of from this episode that I probably wasn't prior is that, if you kind of look at some of the kind of complexities of the abstraction that you enter in, like a simple way to maybe look at it is, maybe I understand Kubernetes really well. And underlying that is probably some container orchestrator. And the parallel that I hadn't drawn until this episode is that even if I don't understand some of the, depths and the weeds of how the container runtime works, it's probably got similar concepts from an orchestrator perspective as my abstraction that I work with, right? So I feel more enabled to like not be as intimidated to go one layer down and know that runtime is probably just controlling some other lower level primitive with a bunch of knobs, right? So it's been a really interesting kind of parallel to draw. And you could take that anywhere. You could start at the serverless level. Yeah, that's maybe backed by Kubernetes. That's maybe backed by containers, right? It just keeps going lower and lower and lower. Yeah.
Awesome. Looks like we can't get Duffy back on the show.
I'm hoping that I'm back. Is this any better? Or?
No, it's really like 8-bit audio quality over like telephone over the satellite connection. Yeah, it's just too bad. Olive, anything else that we forgot to mention?
No, I mean it's super interesting. This definitely ties into the like why Kubernetes episode as well. Everybody has their own sort of automation, and just Kubernetes. I still think of it as it's orchestrator / automation, and everybody has their own. All the. Whoa. Okay, all the people I've interfaced that, everybody's very good at running their own automation. We've all been involved in teams that have written our own stuff to automate stuff, right? To automate our workloads, to make our life easier. And Kubernetes just brings brings a lot of that, that sort of in-house automation to kind of more of a sort of an enterprise level, a sort of a community-driven type orchestration layer. So you kind of get a nice warm feeling that the stuff that you've automated sort of in-house off your own bat is kind of like backed by something like Kubernetes that's actually kind of doing the very same things that you've kind of written in-house. And so, if we're going to kind of go like is it a runtime or orchestrator, if we're kind of sort of tying off this episode, to me, definitely it's kind of in and around the orchestration automation element. And maybe it's kind of my background as well, but like Kubernetes just plays in that space where it just makes the management of your things, your endpoints, the things you need to manage, of which now there's loads, because like if you start going down the kind of microservices container route, you've now got loads of things to manage. Before there was bare metal stuff, and then there was VMs, and now you've got containers. So you're kind of going from tens to hundreds to thousands. And so for something to automate that for you is like great. Because for you to kind of keep maintaining your in-house developed sort of automation, which is, super awesome and does exactly what you need, it just gets a bit more complex to manage when you start going down the containerization route. So enter Kubernetes for that orchestration automation layer, for me.
Yeah. Makes perfectly sense. So my take on this is, if we look at just from a container perspective, or let's say the container ecosystem, we have Cloud Foundry, which uses Diego, but they have this prototype out there, and it's pretty clear where they are moving with using Kubernetes as the orchestrator. We had Red Hat, where they started on OpenShift with their own orchestration engine and quickly realized that Kubernetes is way more powerful and there will be way more momentum, and the design was just better. So OpenShift was redesigned, and it has been using Kubernetes for a while. And then we had companies like Zalando, who are pretty famous and active also in the Kubernetes community there as well, who wrote their own container orchestrator, like Olive said, like your custom built in-house container orchestration solution. But I quickly realized it's just so much labor and burden to maintain this platform, and there's no community around it where you can just Google for, hey, how does it work to get my volume running, right? And so they decided to move to Kubernetes, and one of the biggest users of Kubernetes today. So I think there's also a common theme that we've seen at this exploration of different options, and now consolidating around Kubernetes as an orchestrator, but also, as Joe usually says, it's a platform for building platforms. So it's more than just an orchestrator. But that's what I take out of this episode here as well, even though we focused on orchestration.
That is pretty awesome. Can you all hear me any better now, or is it still terrible?
Awesome!
Perfect.
He's
Perfect.
back.
He's returned. All right.
Back from the dead. Hey.
Yeah, I like that. One of the other things that one of the other things, kind of to your point, Michael, that I think has come up a few times, and it seems pretty relevant here, which is that, like, if you look back in time at the different things that we've built over time, almost every single time when we start breaking apart monoliths and those sorts of stuff, and start adventuring into microservices and those sorts of things, we sort of reinvent that entire world over and over and over again. Like from the point where we define service discovery to the point where we define what the infrastructure needs to be able to provide. We kind of have reinvented this in many cases. And if you look at like pretty much any Fortune probably 1,000 company, you're going to find the skeletons of those of those previous attempts at defining all of these things over and over and over again, right? Where I think the Kubernetes fits in is exactly where I think the Kubernetes piece fits in is it's finally one of the first platforms that's come along that says, like, look, maybe we don't have to reinvent all of that over and over and over again. Maybe we can define primitives that actually get you to the place where you can, just consume them just the way you would, like, some of the primitives that your Java runtime expresses, and get you to a better place to actually start, rather than having to reinvent everything over and over and over again. And that's definitely the power of it, I think.
I agree. Awesome.
So awesome.
Cool.
Anybody else have any other things they would like to say about it?
Yeah.
Yeah, in wrapping up, I mean, it's kind of the same statement I made before, but I'm leaving this episode at least feeling kind of like the difference between the two, in summary, for me, is not that important anymore.
Yeah,
it's
right.
kind of just like breaking it down as layers of abstraction and acknowledging it as such. I think there's definitely value in discerning the two to some degree, but not getting just too hung up on it and feeling like you have to put these rigid definitions in place.
Right. That's a nice way to put it. Awesome.
All right.
Glad we have Duffy back.
Me too. All right. Well, I think if nobody else has anything else they want to discuss on this topic, I definitely got a lot out of this discussion, and we can call it a day. Olive, do you have any closing thoughts? Awesome. All right. Thank you all, and we'll see you all next week. And
thanks. Bye-bye.